Sometimes you'll spot an expression like this, x squared minus 49, and you'll wonder, what on earth can I do with that? It might seem to be asking me to factorise or to simplify, but what can I do with just an x squared take away 49? The first thing to recognise is that this is the difference of two squares. X squared is clearly a squared term because it's x squared, and 49 is a square number. The word difference comes from the fact that you're taking them away. You're finding the difference between these two square terms because you have x squared, take away 49. What can we do in that situation? Well, actually you can factorise, and the solution is quite beautiful. What it becomes, and I think to explain it, it would be best if I just show you the answer and then work backwards. What it becomes is the square root of the first term, so in this case x, plus or minus, but let's start with say plus, the square root of the next term, so in this case the square root of 49, which is 7. Then that is multiplied by, again, the square root of the first term, take away, this time, the square root of the second term. As long as one bracket is plus and one bracket is minus, the order doesn't matter. The order of the plus and minus doesn't matter. The order of the expressions, the x coming first and the 7 coming second, does matter. So we have x plus 7, x minus 7, and we have factorised. You might be sceptical about that. You might think, surely not. Where's he getting 7 from? And that would never come out to be this. What happens to all the x's? Well, let's check it out. Let's times out this bracket. We would have front times front, which is x times x, which is x squared. Then we would have front times back, which is x times by minus 7. Then we would have the back times the front, which is 7 times by x, which is 7x. So we have minus 7x from the x times by minus 7, and a plus 7x from the 7 times by x. You might be able to spot what's about to happen. And finally we have the 7 times by the minus 7, which becomes minus 49. Now if you simplify this, if you collect together like terms, we have the minus 7x and the plus 7x cancelling out. That's why we need the plus in one of the brackets and the minus in the other bracket. These will simply cancel out. And what happens after they cancel out is you are left with the difference of two squares. After the minus 7x and the plus 7x, let's highlight that in red, have cancelled out, you are left simply with the answer, which is x squared take away 49. Let's now practice that in a different example. How about if we had something like 81 take away a squared? 81 take away a squared, and we were asked to factorise this. Again, notice it's the difference of two squares. How can I notice that so quickly? Well, the trick is to see a square number and a square expression, and to notice that they are minused from each other. If you can see those two things, then you know it's going to be the difference of two squares. Just quickly, why is this useful? This is useful for simplifying complex expressions, and it's useful for drawing them graphically. There's lots of different reasons why this is useful. So let's try our trick. Is the answer going to be, to begin with, a take away 9 or a plus 9? No, the order does matter. So we have an 81, so the 9 has to come first, just like the 81 comes first. And we could do 9 plus a first, or we could do 9 minus a first. Remember, it's just a, not a squared, because we take the square root of 81 to get 9, the square root of a squared to get a. So you have 9 minus a, and then 9 plus a. And we have factorised. Okay, let's do a slightly harder example. And this sometimes gets students. If they have a harder example like so, they'll have something like 4y squared minus perhaps 25. And they might say, well, we can't use the trick now because it's not just y squared take away 25, it's 4y squared. But that is a squared expression because 4 is also a square number. It's just that taking a square root is a little bit more complicated. But what is the square root of 4y squared? Well, the square root of 4 is 2, and the square root of y squared is y. So we have 2y, and again, plus or minus the square root of the other expression. So in this case, plus 5, the square root of 25. And then 2y minus the square root of the number. And we have factorized. Any of these solutions, by the way, you might want to double check and see if they go back to the original. And you should find that they do. I'll do a final example because I think you're getting it now. How about if we had a fraction where on the top line we have 9x squared take away 16, and then on the bottom line we had, for example, let's put it down here in the same colour, 36 take away x squared. How could we factorise top and bottom? Well, the 9x squared, the square root of that is 3x, because the square root of 9 is 3, and the square root of x squared is x. And the square root of 16 is 4. So let's do minus 4 first of all. Again, the order doesn't matter. And the same expression again, but this time with a plus. That's the top line. Done. And the bottom line, you might want to have a go yourself first before I give you the answer. But the bottom line would be the square root of 36, which is 6, minus the square root of x squared, which is x, and again the same expression, but this time with a plus. Now you know the method of the difference of two squares. Keep an eye out for those square expressions with a minus in between, because now you know how to factorize and simplify them.